Man 1 to Man 2. I have entered the building, over.
Excellent. Our reconnaissance has informed us of useful chemicals ahead of your position.
I found the chemicals.
Which ones are you to take?
Here's an interesting one. Francium. I'm surprised this hasn't decayed yet, based on its half-life properties, unless they might have developed a new isotope? What else can you tell me about it?
Since francium is the largest of the alkaline metals, it is highly reactive with water, which can be useful for us later, for its effects can be quite devastating.
Right. I don't have much time here. I fear my presence would be discovered soon. I will continue to look for our primary target. Ionic out. Man 1 reporting. I found the tanks.
Excellent. What is contained within the tanks?
Tank 1 contains 500 kilograms of cesium. Tank 2 contains 30,000 milliliters of oxygen at 5 atmospheres of pressure.
The cesium tank will be the best choice for the mission.
I've disabled their security. I'll inform you when I finish the mission.
Very good. Man 2 out.
Andrew, I finished testing some reactions in the lab.
Oh, excellent. I'll be in shortly.
What report are you working on?
I've been documenting the effects of alkaline metals in water. Here, take a read for yourself.
I'm impressed.
Okay, here's a video we're going to submit to the company. It's been edited properly, and hopefully it will bring good results.
In this experiment, I will show how vinegar and salt has an effect on tarnished pennies. The combination of vinegar and salt will turn a penny like this to a penny like this. Watch how this reaction occurs. Over time, pennies become dull because the copper reacts with air and forms copper oxide, which is CuO. By placing the pennies in the salt and vinegar solution, the acidic acid from the vinegar dissolves the copper oxide. The experiment need not be limited to vinegar, as any acid will work, such as lemon juice. The reaction removes the oxidation from the penny, which makes it look new again.
In this demonstration, I will show the effects of vinegar and baking soda combined together. When the two are mixed together, a violent reaction occurs. Vinegar is an acetic acid. Baking soda is a sodium bicarbonate. Mixing the two together is an acid-base reaction. One of the products produced is carbonic acid, which quickly decomposes into carbon dioxide and water. The carbon dioxide is what you see foaming and bubbling in this experiment. This concludes the acid and base experiment.
In this experiment, I will demonstrate how you can boil water using your bare hands. We start with a closed container which contains water, or H2O. I place it on an electric coiled range, which heats the container and boils the contents. Let us define boiling. Boiling is the act in which the pressure of the air is equal to the pressure of the gas within the container. By increasing the temperature of the contents, I also increase the pressure within the container. When the pressure reaches about 101.3 kilopascals inside the container, the water boils. Knowing this allows the experiment to be performed properly. Now the container is placed on a non-heated surface, so it can make it easier to perform this experiment. Ice water is critical for the process because the cold hands lower the pressure inside the container, which makes the temperature lower, and the lower pressure results in a lower boiling point. This has been a demonstration of boiling water by decreasing pressure.
In this experiment, you will witness how a soda can be crushed in cold water. First, the can is placed on a hot surface, preferably a hot plate, but in this case, a grill. As the can heats up, the gas within the can expands. According to Charles's law, temperature and pressure are directly related. Now the air within the can is at a very high pressure. Watch what happens when the can is placed into the ice water. The reason for this is, again, due to Charles's law. The ice water is at a much lower temperature than the air within the can. When the can was placed into the water, the temperature was dropped, and consequently the pressure was too. With the pressure being lower than the outside pressure, the can crushed. This concludes the soda can demonstration.
In this experiment, I will show how static electricity can bend water. Here we will use a comb, a faucet, and a head full of dry hair. First, you need to turn on the water faucet to a very thin stream of water, making sure that it does not touch the comb. Now we are taking the comb and just slowly bending it near the water. If all goes well, the stream of water should bend toward the comb, which it is, as you can see. How does this work? When you brush a comb through your hair, tiny parts of the atoms in your hair, called electrons, collect on the comb. These electrons have a negative charge. Now the comb has a negative charge. It is attracted to things that have a positive charge. It is similar to the way magnets are attracted to metals. When you bring the negatively charged comb near the faucet, it is attracted to the positive force of the water. The attraction is strong enough to actually pull the water towards the comb as it is flowing. The reason for this is due to the polarity of water. As shown in this diagram, the O is negative, while the H's are positive. This causes the bend effect. This has been a demonstration of water polarity.
The video was really good. I hope we get some recognition for it.
I agree. It was put together very well.
Truly a chemical masterpiece.
I agree. Now, we should go back to my office. We need to resume some work.
I concur.
Hello, Chemical Labs Department. Oh, hello, Jack. What's the problem? What? Alright, I understand. I'll arrive with my team as soon as I can. Bye. That was Jack from the bomb department. He has some bad news. Apparently, a week ago, someone placed a bomb at the chemical facility in one of the cesium tanks. Apparently this bomb has an ability to destroy the entire chemical plant. Tomorrow morning we're going to head out to the chemical plant and see what we can do to defuse the bomb. Because in this area we're the best. And Jack really thinks that we'll be able to do it. The door's not opening properly. Try to see if you can get it manually setting. Freeze! Oh, we were trying to get in here because I don't have my pass, but if I get my ID out, I think I'll be all right. There you go.
That was one deadly reaction.
Alright, I traced his path. He's gone from here to this door. This is where we need to go. Alright, so let's go. Yep.
This place is a mess.
I agree.
Wow, whatever happened here? Everything's destroyed in here. We gotta find the chemical room. You hear that?
Yeah.
It's coming from here. This has gotta be where it's at. It's gotta be in here somewhere. This is all Jack told me. Where would he have put it?
Are these the tanks?
Yep. That's right. These are the tanks that are gonna blow up if we don't figure out where the bomb is. Wait a minute. Look. It's the bomb. Yeah, that's the bomb, alright. Alright, now we gotta figure out how to defuse it.
It seems the bomb is hooked up to the H2O line. That means the cesium would react with the water.
Alright, that makes sense.
That would be a deadly reaction.
Alright, let's see. This should be really easy to take off. Oh. Alright, bad idea. We gotta get out of here right now. It's self-destructing. Now, let's go. Let's go. Right now. Come on. All the time. Cesium and other alkali metals and the effect of water.
But still, a deadly reaction.